wanted to make a video just going over how to use dimensional analysis with our metric conversions. Metric conversions are very, very common in medical math. And a lot of people learn how to use the decimal point, moving the decimal point, and that's fine. If you feel like you're good at moving the decimal point, that is amazing. That's ultimately how you're probably going to be doing your metric conversions when you get into clinical practice. But sometimes when we're just starting out, it can be a little dicey, and it's a pretty easy area to make mistakes in. Sometimes we can forget if we move it to the left or the right, or if we move it 3 places, or if we move it 2 places. So dimensional analysis can be a really, really useful tool to go back and check our work and make sure we are converting it appropriately. So let's take an example. Now here are our common metric conversions that we're using in veterinary medicine. And unfortunately, this is just something we have to commit to memory. Just like when we had to memorize our multiplication tables when we were little, we have to memorize how many grams are equal to how many milligrams and how many milliliters are in a liter, and that will help us make these conversions a little bit more smoothly. So let's take an example. Let's say that we have, we'll say we have 245 milligrams. And we are told that we need to convert that into grams. So again, the way that we do this with the decimal place, if we're converting milligrams to grams, we're going from a smaller unit to a larger unit. And when we go from smaller to larger, we move the decimal place to the left. If we're going from larger to smaller, we're moving it to the right. And in this particular case, because there are 1,000 milligrams in a gram, 3 zeros, we are going to go ahead and move that decimal place 3 places to the left. And it's going to give us 0.245 grams. Okay, so there's 245 milligrams in 0.245 grams. Now, again, kind of going back and using our ratios and dimensional analysis to make sure we're doing it right, because sometimes on a test you can just get all flustered and not be sure and start to doubt yourself. You can just go ahead and take 245 milligrams. Now, going back to these metric units, once we have these committed to memory, it's so helpful to understand that these can also be written in the form of a ratio, because they are equal to each other. So we can take this 1 gram equals 1,000 milligrams, and we can say that in 1 gram, there are 1,000 milligrams. That's totally a true statement. Or we can flip it around. We can say that, hey, in 1,000 milligrams, that's going to equal 1 gram. And then we can go back and use these ratios to do our metric conversions. So if we're given 245 milligrams, the way that I like to do this is just set up the problem, set up my little ratio line there. I know that I want to get rid of my milligrams, so I'm going to go ahead and just put that on the bottom so I don't get confused. And I know that I want to get grams for my final answer. This way the milligrams are going to cancel out and the grams is going to be what I end up with. And then I just have to go back to my memory and know that there are 1,000 milligrams in every 1 gram. And this is how we double check and make sure that yes, we are supposed to divide 245 by 1,000 or move that decimal point to the left. So when we kind of break down this math problem, we take 245 times 1, divide by 1,000, we get the same answer, 0.245 grams, and we can be certain that it's the correct answer and that we moved the decimal place correctly. Using another example, let's take micrograms. Okay, we use micrograms quite a bit in small animal medicine. One particular drug that comes to mind is buprenorphine, which is often dosed as micrograms. So let's go the opposite way. Let's go from bigger to smaller. So let's say we have to convert 0.03 milligrams to micrograms. Okay, so in this case, we're going from bigger to smaller, so we would move that decimal place to the right 3 times, because there are 1,000 or 3 zeros in our micrograms. But using our dimensional analysis, we go ahead and set it up. We want the milligrams on the bottom again. We want to get rid of it. And we want the micrograms on top. That's a little mu symbol. Sometimes it's written mcg. And then going back to our memory, we know that there are 1,000 micrograms in every 1 milligram. My milligrams are canceling out. In this case, I'm going to be multiplying by 1,000, and I'm going to get 30 micrograms. So 0.03 milligrams equals 30 micrograms as my answer. Okay. One more example, because this is one that can really throw people for a loop, is our deciliters. Not used that commonly, but when we start talking about blood work and things like that, many things are reported in deciliters. This is where if you're only memorizing to move the decimal place 3 places to the left or right, you're going to get it totally wrong, because deciliters is a 2 placement movement, because there's 100 milliliters in 1 deciliter. So let's say that we have, 650 deciliters. No, that's going to be crazy big. Let's go the other way. Let's say that we have 650 milliliters, and we need to figure out how many deciliters that is. So in this particular case, we want the milliliters on the bottom, the deciliters on top. We know that there are 100 milliliters in a deciliter, and therefore we know that we're going to go ahead and divide by 100. And then our answer, our mils cancel out, is going to be 6.5 deciliters. In this case, we were still going from small to big, so we moved that decimal place to the left, but we only are moving it 2 places because there are 100 milliliters, not 1,000. Okay, I hope this helps. Reach out if you have any questions.